as I mentioned on the notes, sometimes it's easier to start simplifying the radical before multiplying the numbers together. Even though I know what 15 times 60 is, it's easier for me to just start splitting it up. Now, I know that 60 is 15 times 4, so I can just kind of shortcut this, and I've got a pair of 15s, so a 15 comes out, and I can take the square root of 4 because the square root of 4 is technically a pair of 2s, so a 2 comes out. So this actually equals 30. There was nothing left inside except a 1, a factor of 1. So this was a perfect square. It's just 30. Whereas 8 times 24, I don't know what 8 times 24 is off the top of my head. And if I did know it, then I would still have to break it into pieces. So why don't I use these here? Instead of bringing it all the way down to its prime factors to a bunch of 2s, you're looking for a pair of numbers. I know that 24 has an 8 in it, so I'm going to stick with 8, and I'm going to split this up into 8 times 3, and now I've got 8 times 8 times 3, and you have a pair of 8s, so take the 8s out, and the 3 doesn't have a friend to escape with, so you have 8 root 3. Likewise, radicals can get together with other radicals. So in this, you can cancel out the square root of 2 and the 98. You could either put them together under the same square root sign and cancel that to get the square root of 49, which is 7. Or you can actually say, well, I'm going to cancel out the square root of 2, and I'm going to cancel out a square root of 2 in there, and you could turn that into a 49. Now, if we go over here to this one, radicals can get together with radicals, and regular numbers get together with regular numbers. So this 5 and this 6 can multiply together. And the square root of 7 and the square root of 3 can get together. So I'm going to get 5 times 6 is 30. Let's use a pen. 5 times 6 is 30. And 5 times the square root of 7 times the square root of 3 is going to be the square root of 21. Now, square root of 21 is just 7 and 3. It's 2 prime numbers. It's not going to, there are no pairs to come out. So your final answer would be 30 root 21. And the final thing that we would want to work on is what happens when you have a slightly more complex problems. So we're going to scoot this up a little, and we're going to try this out. If you have the square root of 45 over 15, let's worry about simplifying this. So the square root of 45, I'm going to do it over here on the side. Square root of 45 is 9 times 5. 5 is done. And 9 is 3 times 3. So we have a pair of 3s. So 3 comes out. And that lonely 5 is left inside. And it's all over 15. Now, if you remember from the notes above, regular numbers, rational numbers, can get together with other rational numbers. So I can cancel the 3 and the 15. I can cancel the 3 and the 15. So now I get that that is going to be 5, and 3 goes into 3 one time. And so my final answer here is the square root of 5 over 5. One is under a square root sign, one is not. They can't mix together. No canceling. On this next one, instead of multiplying those together, I'm just going to get them together. But this is how I do it, just so you know. I just pretend they're already living under the same square root sign instead of rewriting them like this. I'm just going to pretend they're already together. And this is a 5 and a 2. And this is a 5 and a 7. Now, the one super important thing you can't forget is that there's already a 2 outside. So I'm going to carry that 2 down here. Who else is going to join it outside? Well, there's a pair of 5s, so 5's coming out. And 2 and 7 are trapped inside. So when we do this all the way out, everything is multiplication. We're going to get 10 root 14. And for our last problem, super easy. Do you know the square root of 11? No. So let's leave it alone. Do we know the square root of 36? Absolutely. That's just a 6. And now we've got 2 rational numbers that are even, and we can just cancel them out. 2 goes into 4 twice, and 2 goes into 6 3 times. And our final answer is 2 root 11 over 3. Now complete the 4 next problems. Take a picture and submit them to Canvas.